Cards are drawn successively from a pack of cards without replacing the first. If the card is a diamond, that means if the first card is a diamond, then he's asking what is the probability that the second card is also a diamond. So totally there will be 52 cards, of which 13 will be diamonds. Now, out of this 13 cards, what is he saying is, he is removing successively 2 cards, and the first card which is removed is a diamond. So, if one card is removed, which is diamond, so there will be totally 12 cards, that is diamonds, will be remaining. And out of 52 cards, and also we have removed one card, so you will be left with 51 cards in total. Now, he is asking what is the probability that the second card drawn is also a diamond. So, there are totally 12 diamonds, of which it can be one among them. So 12C1 by, out of 51 cards, it will be one card. So which is nothing but 12 by 51, which is nothing but 4 by 17. That is option B.
Question is, a clay soil has a field capacity of 35%. Field capacity is equal to 35% and the permanent wilting point. Permanent wilting point is 20%. The specific weight of the soil is 12.75. Gamma of soil is equal to 12.75 kilonewton per cubic meter. The available moisture holding capacity in the soil at a depth is 0.8 meters. Considering the root zone depth of the crop, we have to find out the root zone depth. Available moisture content, that is equal to root zone depth. Root zone depth is equal to gamma of soil by gamma of water. Field capacity minus permanent wilting point by 100 into D in meters. So gamma of soil we know 12.75, gamma of water 9.81, field capacity 35 minus 20 by 100 into 0.8, that is equal to 0.156 meters, that is equal to 15.6 centimeters. So option A is correct. Receiving to the question, a reservoir is proposed for flood control. The mean intensity of flood to be controlled is 4 megameter cube per hour in 24 hours. The maximum possible outflow is this much. What is the storage capacity needed for the reservoir? We have to find out storage capacity. Capacity of reservoir is equal to total inflow minus total outflow. Total inflow we know is equal to 24 hours into 4 megameter cube per hour, that is equal to 96 megameter cube. And total outflow, here the statement it was given as mean outflow during filling period is 5 by 6 times the maximum possible outflow. Therefore mean outflow is equal to 5 by 6 times the maximum outflow is given as maximum possible outflow is 0.9 megameter cube. Maximum possible outflow is 0.9, that is equal to 0.75 megameter cube per hour. So total outflow during filling, total outflow during filling, it is equal to 0.75 into, it is about 24 hours into 24, that is equal to 18 megameter cube per megameter cube. So total outflow is 18 megameter cube. Therefore we have to find out the storage capacity of the reservoir. By substituting these two values in the equation 1, we will get 96 minus 18, that is equal to 78 megameter cube. So option C is correct. Here we have to find out the depth of the soil lost in erosion. We have to find out total depth is Z. Let the question is, a sample of clay has been taken from 6 meters below the bed of river. The saturated unit weight of the clay gamma saturated is given as 21.5 kilonewton per cubic meter, and the over consolidation ratio is given as 2.5. Then we have to find out the depth in lasting erosion. So gamma submerged we can calculate, that is equal to gamma saturated minus gamma W, that is equal to 20.5 minus 9.81, that is 11.7 kilonewton per cubic meter. The present effective stress, that is equal to at a depth of let's say 6 meters, present effective stress is equal to P naught, let we say, gamma submerged into Z1, that is equal to 70.2 kilonewton per kilonewton per square meter. So past maximum stress, we know the over consolidation ratio is equal to present stress by past stress. Sorry, past stress by present stress, that is equal to past stress, past maximum pressure is equal to, let we say PC, that is equal to P naught into over consolidation ratio, that is equal to 175.5 kilonewton per square meter. So we have considered the total depth as Z, that is equal to past stress 175.5 is equal to Z into gamma submerged is 11.7. That implies Z is equal to 15 meters. So the depth of soil lost in erosion, the depth of soil lost in erosion is equal to 15 minus 6, that is equal to 9 meters of soil was eroded. So option A is correct. Initially we will collect the data that was given. A 3 meter thick soil stratum has a coefficient of permeability of 3 into 10 to the power of minus 7 meters per second. A separate test gave porosity. Porosity is 40%, that is equal to 0.4, and the bulk unit weight gamma bulk is equal to 21 kilonewton per cubic meter at a moisture content of 31%. Moisture content, that is water content, is given as 0.31 percentage, 0.31 percentage. And what is the head at which upward seepage will cause quicksand condition? Upward seepage will cause quicksand condition. We have to find out the head at which this condition is going to satisfy. We know the relationship between porosity and void ratio and porosity. E is equal to n by 1 minus n, that is equal to 0.67. We know gamma bulk is equal to G plus ESR into gamma W by 1 plus E. We know void ratio is equal to W, water content, Wg by SR. So by substituting this E value in the above equation, we will get gamma is equal to G plus Wg into gamma W by 1 plus E. By substituting these values over there in this equation, we will get the G value as 2.68. The critical gradient IC we can represent is H by L, head causing flow by length of the travel, is equal to G minus 1 by 1 plus E. we know that we know the value of L. The thickness of the stratum is 3 meters. L is equal to 3 meters. So head causing flow H, we can find out H is equal to G is 2.68 minus 1 by 1 plus 0.67 into 3 meters. That is equal to 3.018 meters. That implies option B is correct.